There are two aspects of fabric to consider: the way in which the grains are packed and the way in which the various particles are actually oriented or arranged. Now, theoretically, there are 6 ways in which spheres can be geometrically arranged. And these range from the loosest cubic style, where porosity is 48%, down to the rhombohedral style, where grains have the tightest packing and porosity is only 26%.
The significance of the effect of grain packing on porosity can be seen when trying to pour salt into a salt shaker. The salt in the shaker settles under gravity with a loose packing. Tapping the shaker causes the level of salt to drop. The grains fall into a tighter packing. Porosity decreases, and bulk density increases. Packing is obviously a major control on the porosity of a sediment. Intuitively, one might expect sediments which are deposited under the influence of gravity, such as grain flows and turbidites, to exhibit looser grain packing and hence higher porosity than those laid down by traction currents. It is most probable, however, that post-depositional compaction causes rapid packing adjustments and porosity loss during early burial. This analysis of packing was based on the assumption that sediment particles are spherical. This is seldom true of any sediment except for oolites. Most quartz grains are actually slightly elongated. Sands which also contain flaky grains of mica or clay, and those which are constituted skeletal carbonates, have still more eccentric grain shapes. Thus, the second element of fabric, orientation, is probably more significant than packing when considering porosity and permeability variations, although the way in which grains are oriented has little effect on porosity. It has a major effect on permeability. This block of a typical bedded sandstone consists of quartz grains elongated parallel to current direction, and mica flakes and other particles which are aligned parallel to the bedding. Permeability along the x-axis will generally be at a maximum, and along the vertical y-axis at a minimum. The permeability measured in the z-axis will be generally midway between these two values.